Salam, hello and welcome. Now, last time I was riding the bike, the engine died on me suddenly as I was riding. Luckily I was close to the main road, so it was a matter of phone call. My brother-in-law came and we loaded the bike on the truck and we went home. So I've been struggling to find out what was wrong. What I did is similar to what I did in the misfire video. So I done a resistance test to the stator, to the pickup coil, and to other electrical components in the bike. Then what I did is I checked the conductivity of the switch, main switch, the ignition switch. I took actually the main switch out and I cleaned it inside out. I have put a CDI that I know it was working, just in case that this CDI died, and it was not a case of CDI. I pulled the entire wiring harness out, and I checked the physical condition of the wiring harness in case any wires are cut or so, but everything seems to be good. Then at last, I removed the stator cover today, and this is what I found. So this is the actual problem, and this is the actual issue. The flywheel has broke. Now, this is a machined lightweight flywheel, and I think I was using this one for the past 4 years. Eventually, as you can see, it gave up, it broke. So without having the flywheel spinning, there's no signal going to the pickup coil, there's no ignition. So I believe this is the issue, and as soon as I replace this flywheel, everything should be okay. Now it's going to be a real challenge to replace this. This is a tight nut, and I can only hold to this part, but this will have to be replaced. Now, unfortunately, I don't have impact gun, but I'm going to try to replace it anyway. Now, one takeaway that I would like to highlight here: unless you drive in a racing bike and you're going for a race, lightweight flywheels are total rubbish. Yes, this one served me for 4 years, but eventually it failed. And if I was deep in the desert, it would have been an issue and problem. On the RC cars also, if you are using Genoa or CY engines, the lightweight flywheel, it actually provides insufficient cooling for the engine, and eventually the engine will fail. My advice, unless you are driving a racing machine and going for a race, don't use lightweight flywheels. Just go with the stock. And here's the stock one. Now you can see the difference in mass between the lightweight and the stock one. Yeah, I also forgot to mention that I replaced the ignition coil, which is right here, with one that I know that it works and also give me no result. Yeah, it was the flywheel. Before I start my attempts to remove the flywheel, I'll put the bike in gear, on some high gear. Yeah, it is in first gear now, but it won't go to second, so I'll have to rock the bike back and forth. Second, third, fourth, and fifth. Okay, so the nut on the flywheel is 17 mm. So here I got deep 17 mm nut socket. Park and brake is on. That was easy. Easier than I expected. Now, this is a special tool to remove the flywheel. First of all, I'm going to pull the screw all the way out. Almost all the way. Yeah. And then I'll thread it, engage it with the threads on the flywheel itself. I think this works counterclockwise. Yeah. Just enough to grab it. And I think this is also 17. No. This is probably 19. Yeah. I'll have to tighten the screw And as the screw tightens, it's going to pull this out and pull the flywheel out with it. Okay, that's a challenge. I'll try to use the bigger ratchet. I'll try grabbing this nut while pulling. Yeah, it worked. Now you can see the difference in size between the stock flywheel and the machined one. I would say the machined one was not bad. It was really lightweight, still heavy. All that machining eventually affected the structural integrity of the flywheel itself, and this is what has become. So I'm going back with the stock flywheel. Now, be aware when you change flywheels that there is this small part here. They call it the flywheel key, or actually it's called, the correct name is Woodruff key. And it goes in this groove. You can see this groove. This is the Woodruff key, and it's half moon shape. Okay, so we'll put the flywheel back. Make sure it's seated, and you know that the flywheel is properly seated by checking the back clearance and the clearance here between the magnet and the pickup coil, which is good because it should be a couple of millimeters only. I'm going to use thread locker. Since this is one piece flywheel, the filter wrench will work on it. According to the climber manual, the torque spec for the flywheel nut is 59 foot-pound, and I trust climber manual. So I set my torque range at 59 foot-pound. Now I wish if I had an impact gun. Okay, I'll try to set this up in a smarter way. Okay, what I would like to do is I would like to keep this close to the magnet so the magnet can stop it, apply a stopping force. And that's it. Before I put everything back together, I'll make a quick test to see if I have a spark on that engine now. Okay, so for the purpose of making the spark test, I've put the gear in neutral, I've put ignition switch on, main switch on, and also to make this test easier, I've taken both spark plugs out. I'm gonna give it a few kicks now, and I'll see if I get this fat blue spark. Yes, there is a spark. Don't know if the camera can show this, but definitely there is a spark. So the spark is ready to work now. All right, cool. So I'm going to put spark plugs back. That's it. 2. Okay, so I'm going to put the stator cover back now. I have checked the gasket condition. The gasket, actually the stator cover gasket is reusable, and this one is in good condition. The most important part of the gasket is this part, because this is what keeps dust away from the flywheel, the stator, the pickup coil. Always make sure that the gasket is seated on the mating surface of the cover itself. So you can take it and put it in one piece on the engine. The screws typically as standard comes in Phillips shape, but I have upgraded to hex screws, which is a lot better to deal with. I'm starting with the longer one. At this stage, I'm just putting the screws in. I'm not going to apply any torque. Okay, so now that the screws are all in, I'm going to start torquing. Starting with this one in a 3-inch, just to take more leverage and apply the torque that I would like. Actually, the manual states that these are 9 foot-pound. It's okay if you just torque it by hand. Okay, so first step now will be to install the shifter back, and then I can install the foot peg and the foot protector. Oh, this is a little low. You can always adjust the shifter to your taste, to suit your foot position. Right, then we'll be installing the foot peg. Okay, this part is being held by 1 screw here and 2 screws here with the foot protector. I'm gonna go with this one now. Now I'll install the 2 fasteners that holds the foot protector with the rest of the bike. Alright, and that's it. I'm going to start the engine now. It should work. As far as the ignition issue, it's sorted out, resolved. I hope this was useful to you. Electrical issues with the engine can be tricky sometimes. All you have to do is go and check the components one by one. I checked the CDI, I checked the ignition coil, I checked the stator and pickup coil by conducting resistance test. And this is the takeaway really from the video. And then, well, everything looks nice, everything looked good. And if I didn't open the stator cover, I wouldn't find out what was the cause of the issue. So do your diagnostic, go step by step, do not take shortcuts or skip anything. The process I did to treat this issue can actually apply on almost any engine. It's not exclusive to Yamaha Banshee. Whether you actually drive a quad bike, a buggy or a car, this is the process. You have to check the components one by one until you find out which one is the defective component. I hope this video was helpful to you. Thanks a lot for watching. Take care, be safe, and do it yourself.